Hey everybody, today we're going to talk about graphs of rational functions. So, a rational function is a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomials, okay? And the thing you got to be careful of is on these you got to be careful of the domain, which is usually the denominator, okay? Because remember, a denominator can never be zero. And that's where you're going to want to look at the domain very carefully on these. Okay, so what does this look like? Here we have a rational function. F of x equals x plus 2 over x minus 1. Now your first question should be, what is the domain? So we look at this, the denominator. Remember, the denominator can never equal 0. X minus 1 cannot equal 0. So that means that x cannot equal 1. Okay, so my domain is going to be the set of all x's where x is not equal to 1. Okay, and then the next thing we want to know is, what is the end behavior? So what happens to the functions out on the outside? What does it happen as x goes to infinity? What happens as x goes to negative infinity? Now, here's what's going to happen. When we have a denominator equal to 0, like we would have at 1, we get something called a vertical asymptote. So we'll go ahead and make a vertical asymptote here in a nice bright green, right here at 1. Okay? So, all right, so there's my asymptote. Now, what happens with the vertical asymptote is that you can never touch that thing. You can get as close as you want to it, but you can never touch it. Okay, so then we would look for horizontal asymptotes. So I'm going to give you some rules for horizontal asymptotes a little bit later. Right now, I just want you to go ahead and take my word for it that there's going to be one at 1 on this. So we'll put one here at 1. We'll go ahead and do that just like we did the other one. Okay, so it's got a vertical and a horizontal asymptote. And then what's going to happen is you're going to approach this asymptote as you go to negative infinity and to positive infinity. Now, in order to figure out how that is, we can test a point. So an easy point to test on this thing would be to test the point we'd find f of 0. Whoops. So f of 0 is going to be 2 over negative 1, which would be negative 2. Okay, so it's going to be right here. Now, since I can't cross a vertical or horizontal asymptote, ever, the vertical ones, there is some weird cases where you do cross a horizontal one, but here's what's going to happen is it's going to do something like this. Okay, and then over here it's going to do something like this. So the end behavior of this is as x approaches infinity, y will approach 1 from the top. And as x approaches negative infinity, y will approach 1 from the bottom. Okay? So there is my graph of my rational function. Okay, an asymptote is an imaginary line that the graph approaches as close as you want but never actually reaches it. They can be vertical, horizontal, or oblique. Oblique means they're diagonal. So if I looked at this right here, you can see it has a horizontal asymptote right there at 0. Okay, it gets closer and closer to 0. It never actually quite gets there. Now, over here, we've got a horizontal asymptote right here, 2, and we have 2 vertical asymptotes. One is at -2, and one's at +2. Okay. And then if you look at this one, you can see it has a vertical asymptote right here at x equals 0. But then check this out. It's got this other thing right here. Okay, it's got an oblique one. And the equation for that is x plus 1. That might be wrong in this particular one. Looks like it could be just y equals x, because it's, yeah, we'll just go with that. Whoops. We'll just go with that. That y equals x. Okay, so oblique and horizontal asymptotes are mutually exclusive. So if you have a horizontal one, you cannot have an oblique one. You can, and vice versa, if you have an oblique one, you can't have a horizontal one. You can have all the vertical asymptotes you want in combination with the other 2. Okay, we'll go into those rules a little bit later. In fact, we will do it right here. Okay, horizontal and vertical asymptotes. Let f of x equal p of x over q of x, where p of x and q of x have no common factors. So the best thing to do is to take your polynomials and factor them down as far as they'll go, and then cancel out anything that is the same in the numerator and the denominator. We can talk about that in a little bit, what happens with that. So the graph of f has vertical asymptotes at each real 0 of q of x. So if I have a function f of x equals p of x over q of x, everywhere q of x, whenever q of x is equal to 0, there is a vertical asymptote. Okay, that's pretty much what that says. Or I'm sorry, not that. That right there. Okay. Now, the graph of f has at most one horizontal asymptote. If the degree of p of x is less than the degree of q of x, then the line y equals 0 is a horizontal asymptote. Okay, what does that mean? That means something like this. If I had f of x equals x over x squared minus, 9. Okay, the degree of the numerator is 1, the degree of the denominator is 2. That means the degree of p of x is less than the degree of q of x. This will have a horizontal asymptote at y equals 0. Okay? Every time this numerator has a degree less than the denominator, doesn't matter how much less, it will have a horizontal asymptote at y equals 0. Now, if the degrees are equal, for example, if I had f of x equals, I don't know, x, let's say 2x cubed minus 5 over x cubed plus 2x squared minus 5x plus 2. Okay. That's just terrible looking, isn't it? Okay. These have the same degree, so what I do is I take the two leading coefficients and I divide them. So that would be 2 over 1, which would be 2, and that tells me that I would have a horizontal asymptote at y equals 2. Okay? So this goes with this one. All right. If the degree of p of x is greater than the degree of q of x, whoops, this is supposed to be, that's supposed to be a closed parenthesis right there. Okay. If the degree of p of x is greater than the degree of q of x, then the graph has an oblique asymptote. Okay, so careful, because this is not exactly right. If the degree of p of x is exactly 1 degree higher, sorry for the typo here, so this should go here, then the graph has an oblique asymptote. So what would that be like? That would be something like this. F of x equals 2x cubed over x squared minus 6. Okay, so this is degree 3, this is degree 2. This is going to have an oblique asymptote, and what I'm going to do to find it is I'm going to take 2x cubed, and I'm going to divide it by x squared minus 6, and that would be a 2x, so that would be 2x cubed minus 12x, and I subtract, so this would be 12x, and that's a remainder because that's less than this, so it would have at y equals 2x, it would have a oblique asymptote. Okay. Now, if it's more than 1 degree higher, let's say I had something like f of x is x to the 4th over 2x squared. It does not have an oblique asymptote. So I would look at this one and go, oh, this has a vertical asymptote at 0, and that's it. No horizontal, no obliques. Okay? All right. So what do we got here? Sketch the graph of the function f of x is 5x plus 1 over x squared minus 1. Okay. So the first thing that we know, the first thing we're going to do is we're going to factor this. So the top is already as far as it'll go. The bottom will factor to x minus 1, x plus 1. So that tells me that this thing is going to have a vertical asymptote at 1, and it's going to have another one at negative 1. Okay, it's also going to have a horizontal asymptote at 0 because the degree of the numerator is 1 less than the degree of the denominator. Okay, now I just got to figure out what the graph looks like. There's a couple other rules I'm not quite going to go into yet. You'll get those later. But probably the quickest, easiest way that I can do this at this point is I'm just going to pick a couple of points and plug them in. So I've got 3 regions. I've got this region over here, I've got this skinny region right here, and this one over here. So what I'm going to do is I'm going to pick a point like, I'm going to find, say, f of negative 2. So that would be 5 times negative 2 plus 1 over negative 2 squared minus 1. So this is going to be negative 10, negative 9 over 3, which would be negative 3. Okay, so negative 2 would give me negative 3 right here. So what this is telling me is this is going to look like this. Okay. And then I can pick a point over here. Let's say I chose 2 this time, so I found f of 2. So that would be 5 times 2 plus 1 over 2 squared minus 1, which is going to be 11 over 3, okay? Which is about 3 2/3. Okay, so that would be 1, 2, 3, about right there. That's telling me this is going to look like this. Okay, now I got to figure out what's going to happen in the middle. Okay, so what that does is we look at something called multiplicity. Multiplicity is how many times these factors occur. Okay, so this occurs once and this one occurs once. So they have multiplicity of 1, which means that they're odd, because 1 is an odd number, which means at each vertex it's going to go down on one side and up on the other. Okay, so what I know is this thing is going to look something like this. It went down on this side, so on this side it's going to go up this way. And this one went up on this side, so it's going to go down on this way. I just got to kind of find out, where it does it. So I'm going to try, f of 0. That's going to be 1 over -1, which is -1. So that's going to be right here. Okay, and so this thing's going to go like, it's going to go like this. It's going to come down here like this, and go through there, and it's going to go like that. Okay, if this was x minus 1 times x minus 1, that would have a multiplicity of 2. That would mean that's an even one. That means it's going to go either up on both sides of the asymptote or down on both sides of the asymptote. So maybe we'll look at one of those a little later here. Okay, so here we've got this one. G of x is negative 2x squared over x squared minus 9. So we got to factor it first of all. So the top is already factored. The bottom can become x minus 3, x plus 3. Okay, so once again, I'm going to have at 3, I'm going to have a vertical asymptote. And negative 3, I'm going to have a vertical asymptote. I actually said those backwards. And, now, the degrees are the same, which I'm going to take these two whoa, don't want that. I'm going to take these two things right here, and I'm going to divide them. So negative 2x squared divided by x squared is negative 2. So this thing's going to have a horizontal asymptote at negative 2. Right there. Okay, so again, it divides this thing into 3 regions, doesn't it? So I'm going to pick a couple of points and graph them and find out what does this thing look like. Okay, so let's pick something like negative 4. We'll find f of negative 4. So that's going to be negative 2 times negative 4 squared over negative 4 squared minus 9. So this is going to be 16, negative 32 over 16 minus 9, that's going to be 7. So it's going to be negative. It's going to be a little more than negative 4. So 1, 2, 3, 4, it's going to be right about here. So this thing's going to look something like this. Okay? And then we'll go ahead and check f of 4. So f of 4 would be negative 2 times 4 squared over, so that's going to be negative 32 on top again. And then 4 squared minus 9, so that's going to be 16 minus 9 is going to be 7 again. So it's going to be the same thing. So it's going to be right about here. This thing's going to look like this. I'm not looking for an exact graph here. Okay, now, if I look at the multiplicity, this one has a multiplicity of 1 because there's to the 1 power. Both of them have a multiplicity of 1, which means that on each of these vertical asymptotes is going to go down on one side and up on the other, which means this thing in the middle is going to do something like this. It's going to be U-shaped. I just got to kind of figure out where it is. Okay, I'm thinking since 0's in the middle, that's probably going to be the bottom of this thing. So I'm going to go ahead and find f of 0. which is going to be 0 on top and negative 9 on the bottom, which is 0. So this thing's going to hit the origin right here, or hit the, whoops, it is going to hit the origin, not that point. It's going to hit right here. Okay, and I'd kind of like to have a little bit better idea what this is, so I could pick a couple of points I could find. It looks like it's going to be symmetrical. So I'm going to go ahead and find f of 2, because f of 2 is pretty easy to find. So that would be negative 2 times 2 squared over 2 squared minus 9. Is that right? Yep. Okay. So this is going to be 4 negative 8 over negative, what is that? 4 minus, that's going to be negative 5. I'm sorry, just negative 5. Okay, so this is going to be 8/5. All right, 8/5. That's 1 3/5. It's going to be right about here. And then I'm going to have a symmetric one right about here. So this thing's going to look like this. And there you go. So that's pretty fun, pretty cool to do. All right, what do we got here? I tell you what, why don't you pause the video and give this one a stab and see if you can do it on your own. And then jump back on and see if you get the same thing I do. So go ahead and pause the video. Okay, so here's what I know. This thing's going to have a vertical asymptote. It's already factored. It's going to have a vertical asymptote at negative 2, because that's where the denominator is going to be 0. So I'm going to go ahead and put that in here. Okay, so there's that. And then since x squared is 1 degree higher than x, this is going to have an oblique asymptote. So I'm going to go ahead and take x squared, and I'm going to divide that by x plus 2. So I need an x. X times x is x squared, and 2x, and I subtract that, and I get this, and that's going to be my remainder. Okay. Oh, no, it isn't. That'll go in there negative 2 times. Negative 2 times x is negative 2x. Negative 2 times negative 2 is, or positive 2 is negative 4. I subtract that, and I get 4. That's my remainder. Okay, so I have an oblique asymptote at y equals x minus 2. So I'm going to go ahead and put that in. How'd I do there? And, uh-oh. I want to go all the way across the graph if I can. All right, so there's my two asymptotes. This will not have a horizontal asymptote. Now, one of two things is going to happen. This thing is either going to go in here like this and up here like this, or it's going to go like this here and like this here. So we need to figure out, you know, what's this thing going to do? And so let's just pick a couple of points. Let's find f of 0. Okay, f of 0 would be 0 over 2 in this case, which is just 0. So 0, 0 is going to be on the graph. And pretty much right now I know exactly what this thing's going to look like. Okay? I don't even really need to put any more points in unless I need to get really accurate. I might, you know, f of 1. Here's what I know it's going to look like. It's going to look something like this here, and it's going to look like something like that down here. So f of 1 would be 1 over 3, which is just 1/3. Okay, so that's going to be like right here. This thing, yeah, I might do -1, 2 just for fun. So that would be 1 on the top, and that would be 1 on the bottom. So that's going to be 1. It's going to be right here. So this is going to go like this. It's going to approach that line. It's going to curve up here like this. Okay. Now, here's what I'm going to do. See, if I go from this vertical asymptote, I go over 1, 2 points, I get this point right here. I want to go I want to go 2 over this direction. So what if I picked, this would be 1, 2, 3, 4. I'm going to choose -4 and see where that ends up. F of -4. Okay, so that'd be 16 on the top. And that would be -4 plus 2 would be -2. That's going to be -8. That's going to be way down there. Let's see. -4, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right there. Okay. And this is going to go like this here. And it's going to go like that there. Okay. If I go from where these intersect right here, if I go up 1, 2, 3, 4, and to the right 1, 2, I should be able to go down 4, 1, 2, 3, 4, and to the left 2. And up, I got that same spot. Okay. So hopefully that's what you got. Here's a few problems for you to play with. A couple of graphs on the end of that. Have fun with that. I'll talk to you later.